Good morning, everybody. Thank you for coming to the Mach Machines Delfoi webinar. We appreciate your attendance, but your attendance is also indicative of your company's willingness to embrace technology that is inevitably the future of programming robots. With us today is our Delfoi team from Finland, as well as the Mach Machines team from all over the US, but primarily Cincinnati and Alabama. Birmingham today. And our Master of Ceremonies is going to be Anthony Johnson, who is an expert in the field of fabrication and manufacturing, especially as it relates to software that automates the operations in these fields. So Anthony, why don't you take it away?
Excellent, thank you. All right, my screen is coming online right now. Let's see. Starting the slideshow. Can everyone see my screen? Is it coming across okay?
Looks good.
All right, thank you. All right, well, welcome to our webinar today. We've been very diligently planning a good conversation for you. We have quite a bit of thought-provoking things as far as manufacturing is concerned, and we want to make sure that we have a great meeting today. The first thing that we want to talk about here's our agenda for today. Yandre has already provided the opening words here. I'll introduce a little bit of our Delfoi software portfolio and Mach Machines software portfolio that we serve our customers with. Then we'll go through a full demonstration of how we help customers with our tools inside the software. Then we'll talk about fixturing software as well. And then we'll provide about 20 minutes for questions at the end. And then we'll end about 11:30. Practical information, everyone is muted, but that doesn't mean you don't have a voice here. And this is a passive participation. We want you to participate. We want to get your questions answered. So feel free to go to the question control on your webinar controls there and type in any questions that you may have. If it's something that we can answer in the different sections as we go by, we'll stop and answer those. But we'll have a big question and answer time with all of the panelists, fixturing, robot programming, how we help customers. We'll be able to talk about that at the end. But please feel free to ask those questions that you have. So we've gotten the opening words from Yandre right now. I think we're going to transition just to how we help people at Mach Machines. Let me get that slide pulled up here, and I'll show you how we help people. Essentially, Mach Machines is based in Cincinnati, Ohio, in actually Blue Ash, Ohio, very close to the manufacturing corridor and technical corridor here in the United States. Lots of robot manufacturers have their home in Cincinnati, Ohio, so we can help serve their customers directly. We can even go to robot manufacturers' headquarters and work on your particular implementations. Who's in the room today? There's quite a few people that we've interacted with and invited to come to this webinar. We have customers that are very heavily invested in robotic technology today. There are people who are invested in welding and curious about robots, and there are people who are trying to do what they're trying to do better and just are technology enthusiasts. We have something for everyone, and hopefully you'll get something out of our meeting today. Our founder, Yandre, and I have lots of experience in the fabrication and manufacturing world. We came from Sigma Nest, which is very easy to use software for nesting and sheet metal nesting, and the same concept we have for sheet metal nesting, spending very little time with the software, is the same technology we want to offer to customers with robotic programming and other things that we offer. The manufacturing today, it is very challenging to find the people that you need to do the work that you need. So the people who do show up often are tasked with more things to do. So we want you to program your robots fast, and for that we use Delfoi Robotics. We have a planning tool that helps production control and operations management adjust when there's material shortages, or you are missing a key person on a line, or a line goes down, help you get production out the door and help schedule automatically. If you're interested in having that conversation, you can talk with us later about that. Then we will have some time where we'll talk about our fast fixture creation partner here with Camtech. And then we also offer plant simulation tools that is the base level of our software. Let's see if this navigates. There we go. The people we have in the room today with us, the first people that are going to discuss their product is Delfoi. They have the easiest to use, world's easiest welding software for robots, and they offer us the planner as well. They also have plant simulation and lean consulting conversations they can have as well, but they have the most experience in robotics, and you'll see that come out as we talk about our products and services. Who is Delfoi? They have products for all of the robot applications, but I'll tell you that the hardest one, the most challenging, is welding, and we have solutions for cutting and finishing and polishing, as well as painting. We have customers that you've heard of, but all that means is there have been people that have recognized that Delfoi can help them do what they need to do. We support all major robot brands. So most major robot brands, I'm sure there's a couple out there that we haven't done yet, but we would love to try. But most major robot brands that you've heard of, we are controlling and supporting. Here are a couple questions that we typically ask. Are you still manually welding? And if so, are you hiring more welders? That is a challenge. There's a company here in Alabama that hires 9 robots, 9 welders to keep one. It takes them 6 months, and it costs them $250,000 to get one welder to show up and pass a drug test on the shop floor. It is a challenge to hire more welders. In addition to having them show up and be competent, robotic welding is a much faster solution. You can, it should be a third or a half the time a manual welder can weld, because there's much fewer air moves. We can get more consistent quality, and they are available more hours than a human welder can provide. But there are some barriers besides the known barriers of how big is your part. Other barriers like that any robotic application would have to do, or any new CNC equipment would have. The barriers typically come about 6 months after you get a robotic welding cell, and you ask 2 questions, and that's why the point of our webinar today. How do I program my robots faster like my other CNC machines? Your lasers, your mills, all are programmed very quickly, and you can get code out to the cell and press go. Also, how do I make my fixtures faster and cheaper if I'm putting more parts on my welding robot? So those questions are the questions we hope to answer today. And to start, we want to just jump into the software. So to do that, I've invited my friends at Delfoi to help us walk through the software. And the first one we have joining us today is Vidisha. And Vidisha is an expert at, she's an expert at Delfoi, and she will show you the tools that our customers use to make their life easier. And that's what I want you to notice in what she does. Vidisha will be able to click very easily through the CAD model that she's going to be programming. But be thinking about this. Who would you put as a robot programmer today? We want it to be as easy to use that a welder from the shop floor can be able to use our software. So Vidisha, I'm going to share my screen and make you the presenter here, and then we can go into the software a little bit more so you can get a peek of our tools that we use to help people.
Hello, do you see my screen and do you hear me properly?
Yes, we do.
Okay, great. So hello everyone, this is Vidisha. I'm application engineer at Delfoi. And today I'm going to be giving you a higher level glimpse of the Delfoi ARC 4.2 workflow. On this slide over here, I have the 4 steps in the workflow that we will cover today. So let's get started with the first step, that is to create the weld path. So in the software, whenever you want to create a weld path, you just need to point the mouse wherever you want to create the weld. And the software has the capability to identify that particular CAD feature as a weld seam. And then you just click your left mouse button and you will get this path generated. The next step in the workflow would be then to create a search program. So with the search, you have the possibility to compensate for any deviations that might occur due to the position or shape of the workpiece. So this is also possible by doing the either a manual search or auto search. But today we will look at the auto search option when I go through more in the presentation. So once you have created the weld program, the search program, and your whole program is ready, the next step would be to validate the program. And to do so, we have the path check functionality. And with this tool, you can check if there are any issues with respect to reachability, joint limits, singularity, or collisions. And you can see that for every problem, there is a color code associated. So when you run the path check tool, you will get a timeline of the program. And you can see these color codes here. And you can see the percentage of the program that is correct. So right now, in this case, 98% of the program is good. But then we have here, let's say, what is this? This is collision, and we have the joint limit issues. So what you can do is you can go to this specific point in the program and rectify the issues until you get 100% correct program, and then you're good to go. So the final step in the workflow would be to post-process the program. And depending upon the robot brand you're using, you can choose the robot from here, click on download button, and the program is then ready to go on the robot controller. Okay, but let's now see the same steps in a layout to get a more better understanding. In here, I have got an ABB robot, which is on a 3-axis gantry. And I have here a 1-axis workpiece positioner. So let's begin with the first step here, as we saw, to create the weld path. And for this, we have here the create path tool. I click on this. And as I do so, I'm going to get this green picking surface. Now, I go closer to where I want to create the weld. Now, let's say in this case, I want to create a weld on the seam over here. So I zoom in closer, point my mouse there, and let's see. This looks good. So I will left click the mouse button, and you can see that now the weld is now generated. And also you can see that we also have here the PA welding position. So the software automatically calculates the welding table positions, and you're able to choose it from this window over here. Okay, so that looks good. Now, once the weld is done, the next step would be to create the search. So as I said earlier, you can do a manual search, but in this case, let's see how to do the auto search. So auto search is like basically it will automatically generate the search points for you for that particular weld. So now when I click on this weld, I click on the auto search option, and there you go. You can see that we have the search automatically generated by the program. Let's zoom in a bit closer. And I click the search, and you can see that, okay, we have got a three-dimensional search at the beginning of the weld there. Okay, good. And other thing is that this is an auto-generated search, but we do have the settings here for this auto search, so you can customize this based on your application. So for instance, you can choose whatever your touch sensing type is, if it's a wire, or if you're doing the touch sense with a nozzle, or if you have an external device such as a laser or a camera. And then of course you can also select that if you want to have a search just at the beginning or in the middle or at the end and so on. And you can also change some other parameters, how the search is going to work based on your application. Okay, so now that we have the search, weld, and let's say this part of the program is done. So next step in the workflow would be to validate the path. So let's go here and take this path check tool. I click here, and then I can check the whole program or a subroutine or selected statements. And let's see, let's check the whole program. I click on check, and it does the check for the whole program. And then you can see that here we have got this timeline. Let's make it bigger. The program is 99% correct, and we have got some collision issues here. So let's go and check those out. I'm going to make the detectors active so that we can see also in the 3D window. Okay, so let's see that the problem is at the search. So I activate that, and this is the second point of the search, and there is some collision with the nozzle there. So we can quickly go here and unlock the second touch point, and let's try to get it away. And that already looks a bit better. Let's move on to the next problem point. So I go there. Okay, and let's double click to get the problem point on, and let's zoom in closer. You can see over here again, this is the beginning of the weld, and the nozzle is hitting a bit on the edge because there are walls at the beginning here. So for this, we can try to use the flare option here. So you have the flare at the beginning of the weld so that it does not collide with the wall. So that looks good, and let's check the program now. Okay, there you go. And now you have 100% correct program. And you can also see the status here that it's green and the weld is okay. And what else I can do from this path check tool is I can jog this slider here, and you can see that the robot jogs through all the motion paths over here. And so this is basically the same way as you do the simulation, but then this is quite handy as you can also go back and forth and check the robot motion. Okay, that looks good. And one more thing from here is you get the weld report tool. And with this report tool, you get the total time of the process. You get the percentage of the welding time, and you get the percentage of the wire time, as well as the weld length there. Okay, so now the program is good. We have validated it. And the last and the final step would be to download the program or to post-process the program. So we go here. We see that our robot is ABB, so download the rapid file. And let's download that file. Okay. And let's see. So we have the, okay, I'm not going to go through the code, but yeah, just to show you that we have the program here ready, and that can be then put onto the robot to weld. Okay, but this was from my side, and I hope that you guys got a overall understanding of the basic workflow that we have here at Delfoi. Thank you for your attention. So
Thanks,
Anthony,
Odisha.
we have, yeah.
Yeah, thank you very much for your help here. I'm going to move on to our next speaker here. Our next speaker here is going to get a little bit more nerdy in the software. We've showed you the basics. It's pretty easy to use, but let's talk about some advanced applications that we've worked on here. My friend Juha is the Senior Project Manager in Delfoi in Finland, and he's going to talk about features for fast programming and multi-robot systems and jigless welding, some advanced applications, maybe unlocking the potential for some integrators in the room or so robotics representatives and customers who we don't want the limitation for your configuration to just be hardware. We want you to be able to do anything that you'd like to do. So I'm going to change presenters and make Juha the presenter here and have Juha show us how we can help you on advanced applications.
Thanks, Anthony. So can you hear my voice and see my screen?
Yes, very good.
Okay, great. So I have two topics in my presentation, so I will be going a little bit to the advanced features. So we are saying that we are fast in programming. Vitisha already showed you this one-click weld path generation using alt search and calculating external axis. What I'm going to show or talk about is about our cloning tool and also about our feature template concept, which basically lets you to design and quite automatically to generate your programs for your parts. And after this part, I will talk a little bit about multi-robot systems because they are getting more and more present in manufacturing nowadays. So we support different kinds of systems where you can have multiple robots working together on one positioner, for example. We are supporting jigless welding applications, and we are also supporting this robot as positioner concept very well. So that is what I'm also going to show you with software. So that's the PowerPoint part. So I will jump into the software. Anthony, can you see the software screen as well?
Very good. Looks great. Can you move it around?
Yeah, I hope it.
Yeah. Looks great.
Okay. So let's start. I have this 3-axis Java layout where I have a 3-axis robot positioner, 1-axis workpiece positioner. On the right-hand side, with this workpiece, I'm going to show some examples how you can use cloning and mirroring tools, which will make your programming pretty fast. So first of all, I need to create one weld path over here. Let's put it over there. So I have a little bit straight, a little bit curved weld in this weld path. So this is the one-click programming magic. Let's go on with cloning tool. So I will select this one weld over here, and then I will be using our cloning tools. On the right-hand side, you can see the user interface where we have quite a lot of different options that you can use. In this case, I'm going to use so-called vector clone, so I can just pick a couple surfaces from the first and second feature, and then with my mouse scroll, I can just add the number of how many clones I want to create. So you can see in this blue color, you should see a preview of what you are going to have. And if this looks good, I will hit apply, and the software will do the clones for us. And once again, when you use this cloning tool, you can see that the robot positioner is calculated automatically so that you can reach the weld every time. So that is a linear clone. And okay, we have the symmetric workpiece over here. So the next thing I'm going to do is to mirror these 4 welds on the other side of this workpiece. So I will use mirror clone, Let's zoom in a little bit closer. I can select the plane. So from this surface, I will start. This is my second surface, and apply. So now you can see that we have all the welds on the other side as well. And if I will select one of these welds that we just mirrored, you can once again see that the software calculated all the external axes automatically based on my selections that I had inside this weld. So I had selected face down position. Okay, so that's cloning and mirroring. Of course, there are lots of different options over here, but this is the baseline what we have. The second thing I'm going to show with this workpiece, which is our feature template concept for really fast programming. The feature template, well, what it really means, it means that you can design how you want to weld this or some part in your assembly. In this case, we have this quite simple construction part in this layout. And I have already programmed a couple of searches and a couple of welds for this one plate that I have in this assembly. So, okay, we have a start point search for this first weld, and we have a start point search and the other weld on the other side. So this is how I want to program this kind of parts. Well, let's save this template. Program, export template. We will save it to the software database. So there it is. I can actually delete this one, and maybe I will just create a new sequence. So we have that defined how to weld this kind of part. In this assembly, we have similar parts over here. We have kind of similar part, which is just a little bit shorter. It's in a little bit different orientation, also over here. So what we can do, import template. Okay, let's see. I want to generate this program in sequence 1 that I just created over there. Well, because we have different size of parts, I will let this software to scale the welds in case there is a different size of part. And then I will say that, okay, import immediately auto select template. So in my database, I could have, like 100 different designs for different kind of geometrical features. And the software is capable of selecting the correct template based on the CAD structure tree of this assembly. So in this case, what I'm going to do is I'm just going to pick the component, wait for a few seconds. When the software doesn't work, maybe I can drink a little bit of coffee, and then it's done. So you can see all these weld parts over here. So based on that one template that I saved, and then I imported it, the software went through the CAD structure of the assembly and created all these parts. And of course, after this, I can use this checkpath tool that Vidisha already showed you to verify if this program really works. Let's see, it's checking some collisions and going through all the points if we have any problems over there with joint limits or something like that. I'm drinking some coffee over here. And yeah, we're done. So everything is good, 100%. Looks great. So then I can just quickly watch through the program. I'm not running any simulation. I'm just sliding this back and forth, this path check tool that we have. And we would be ready to download the program. Of course, you can resequence this thing over there, and we will have some automatic sequencing tools in our releases. And by the way, if someone is thinking, what is this gray part over here in the check path, it means that because in this case we are using a nozzle, we are using touch sensing with nozzle, and of course the nozzle will hit the part. So we are kind of leaving a couple millimeters unchecked before and after that touch point. So that's why you see these gray colors up here. So that is how the feature template works. Actually, I can show another example, just doing it a little bit different, because before I was using this hit component option over here, which basically creates the sequence based on the part structure inside this assembly. So if in this situation, if you now already want to select the welding order, you can use big feature. So if you want to weld from inside out, for example, you can choose that one first, then that one. So this is a little bit more manual, but basically you are just showing what is going to be your welding order for these parts. Yep, and we're done again. Great, so that's about feature templates. Of course, there are lots of details behind this, and we can talk this later with if you want to create another demonstration or something like that in the future. So that is cloning and feature template. And the next thing I was about to show is this multi-robot system. I'm not going to do too much programming in this layout. I'm just going to show you some simulation and just to give some understanding what all our software can support. In this layout, we have KUKA robots. We have 2 assembly robots. One on the left-hand side over there is kind of a main robot here, so it's picking a base part for our assembly. Then we have another assembly robot over here on the right-hand side, which is going to add parts to that assembly. So here we are talking about cheapest welding. And of course, we have a welding robot. And let's see how this thing works. So let's see. I hope this screen refreshes well so that you can see what happens in the simulation. Here you can see we are having a re-grip station over here so that our part is always correctly on our robot hands. So that was the assembly part. Then our robot is going to do some tack welding over there. And then it would continue with final welding. So we are doing some touch sensing over there, and we are doing some welding like that. So we have here part handling operations, assembly operations, and we have welding operations. And one nice thing or feature in our software is that we support this concept where you have a robot as positioner. Of course, you can do this with many softwares, but in our software, the special thing is that we can program this as easy as you would program a 1- or 2-axis simple positioners. So let's try to see how it looks like. So if I will create a new weld path, I will say that, okay, we have a master slave situation over here. And let's see, synchronize page. And the rest is like what you have seen before. So you will just pick your mouse, okay, that looks something that I want to weld. One click and you have your weld path. And what really separates us from some of our competitors is that we have very simple control tools to calculate this positional robot over here. So I can select from here if you want to weld in flat, if you want to weld in base down, or down position. So you need to just click this one button. And also you can choose if you want to let this assembly robot move during the welding, or if you want to keep it still and let the welding robot do all the movements. And also you can change some other orientations like this. This is mostly if you have a reachability issues or something like that. Just scrolling your mouse, clicking these buttons to select the position for these three robots. Yes, that is what I wanted to show about these multi-robot systems. If I go back a little bit to this PowerPoint presentations on the right-hand side, over here you can see once again these different scenarios that we support. So you might have two robots working on one workpiece positioner, fully coordinated, or maybe you have just a robot as workpiece positioner or sequence welding layouts. So we have all the areas supported. Thanks.
Thank you, Juha. There's a couple questions that came in. Are you game to answer a couple of them right here in the middle of our presentation?
Yeah, should be.
Okay. So you showed that the Louis DeCare said the track X and Y and Z axis were generated automatically.
Yep. Exactly.
Okay.
So we have this, let's go over here, for example, to this first part that we have. So the axes are generated automatically, yes. And over here on the right-hand side in our auxiliary axis tab, there are some control parameters that you can change. Once again, just by scrolling your mouse, you can see if you want to change this control parameter, and then you will get a little bit different result, because for this robot positioner, there is almost an unlimited amount of different configurations or solutions to reach this one point.
Okay. Thank you. I hope that answered that question. And then someone asked, can we adjust the paths between the clones while the robot is traveling between them without welding? The air moves, can we adjust the paths, the via points?
Yeah, so basically the default thing is that we are programming automatically approach and departure points for the welds. So that was the first weld, that was the second. And the points between is just from moving from the last point to the first point. And of course, if you want to add or remove points in between manually, you can do. Everything is supported. So first of all, in our path tab, we have this parametric way where how you can change the location of these points. You can remove them, you can get them back, or you can just pick this handle over here. You can move your robot wherever you want. You can touch up that point over there, or you can add another point here manually. And in the later release, and this year when we are going to release our new AutoArc package, there is a possibility to solve via paths between welds automatically by the software.
And we can talk about that a little bit more. You know, if there's a clamp in the way, you certainly want to make sure there's no collisions, and there's some tools that make it very easy for us to do. One more question here, and we'll move on to the next section. Is there a geometry limit for using the weld template? Is there a constraint in terms of shape of part?
Not really, but to use the feature template concept, you need to have your CAD structure good. How would I say it? Sorry. You need to have your CAD structure well.
So if
Or
I'm
I
understanding
should
you, if I'm understanding you correctly, the weld feature template is one of the most strong tools in our library, in our tools of Delfoi here. If you program, let's say you have, 4 or 5 parts sitting, and you don't have a track, you have a fixed position robot. If you program one part or one section of a part and do all the work, multi-pass welds, you get it like you want it, the offsets, the feed speeds, everything about that particular feature, like weld buckets on an excavator. You can program one tooth of a bucket and then take that weld feature, import it in, and click, click, click on all the other teeth, and the robot will move into the correct position and do all the calculations. You don't have to. If you can imagine in a fan shape, the first part is much different than if you have 5 parts, the 5th part. And that is all done automatically, and it's very, very quick. If you program one part on a positioner, let's say on this headstock, tailstock position, you've got, if you don't have a track, that first part is on the left side. You have 2, 3, 4, 5. That 5th part is on the right side. You program one and then use the feature template to click, 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 click on what, on those features, on the additional parts, and you're good to go. And they can be as complex as you want. To answer the question, you can, it can be as complicated as a feature as your CAD allows, but you have to give us as detailed of CAD as you give us is as detailed of programming we can offer, if that answers the question. Okay, well, thank you very much for your presentation. Now we're going to move on to advanced features, new features coming up in Delfoi Robotics, and our friend Vesa. Let me share my screen here. Our friend Vesa will be talking about that. Some new features. He'll be talking a little bit about paint. He'll be talking about some advanced features that we are going to come out with next. So let me transition to Vesa.
Okay, hello everybody. This is Vesa from R&D team of Delfoi Robotics. I hope you can hear me and see my screen already.
I cannot see. Are you sharing your screen?
Yes, on my end it says at least that people can see your screen.
Okay, great. Can you see it?
I can see it.
Okay, great. Yeah, go ahead.
Okay, very good. I hope everybody else can see it also. Just send some chat text to the chat window if you don't. Okay, so first I'm going to share some light of what else you can do with robotics, Delfoi Robotics applications other than only arc welding that we have been talking about so far in this webinar. So basically we have quite many applications. Each application is, the purpose of each application is for a different process. And Delfoi Arc, what we have been now discovering in this webinar, it's not only for arc welding. It can be used also, for example, for TIG welding and laser welding in just similar way that you saw in previous presentations. But then we have Delfoi Cut, which is for deburring, trimming, plasma cutting, laser cutting, and similar, let's say, outside edge detection of the plates or parts is the rule there. And then we have a new application just released, Delfoi Spot, mainly for spot welding. And then Delfoi Basic also just released. Many customers asked this one that you should have this kind of a easier basic version for just to move parts around, grab and release functions, etc. For example, for machine tending and material handling processes. And then on the right hand side, Delfoi Paint, which is targeted for wet painting, and it's behind the line because it's not officially released yet to any customers, but it's in test use on some projects, just to get some feedback before we are brave enough to officially release it. But it should be Q4 in this year when is the release date. So let's check what is all these applications what we have. I just run through these slides and videos quite quickly because we are a little bit limited in time. So Delfoi Basic, you can see it on the video right hand side that how it basically works and simulates part handling, machine tending. You have these easy tools to create tool chains and IO signals, grab and release. You can detect collisions and you can check your motion paths automatically, as you saw also in our Delfoi Arc demonstrations. And then next one is Delfoi Cut. And in this video case, Fastems, which is our partner and software reseller of Delfoi Cut also, you will see a deburring demo or simulation how to use the actual Delfoi Cut application. So similar way what you saw in Delfoi Arc to create arc paths by finding the intersection of two plates, but instead here you're finding the outside edge of some parts or plates. And based on that, we create perfect paths. For example, in this case on the motor block, we create the circular path, and then we can edit the same way what we did in Delfoi Arc, the paths a little bit to compensate the tool and then rotate the wrist a little bit to get better reach. And then again, nice cloning tool there to get all those 4 circles done with the same orientation of the tool, same speed, same parameters, etc. On top of this automatic detection of the edges, we have added a new functionality that if you want to, for example, polish the surfaces, you can import CAM APT files from CAM systems and also G codes depending on what you need, because those other softwares are made for surface detection and they are making really nice paths on the path. So we are not trying to make or discover the wheel, or how you say it again. So that's why it's just easier to import the paths on the surfaces from CAM softwares, and here we concentrate on edge processes. And then Delfoi Spot. This is also a very new software or application, and in this software you can create spot welds manually by just picking with the mouse where is the location of your spot point, and you can easily modify it like in other applications also. But then you can also solve the point automatically, so you don't have to modify it. The software can automatically find out which is the perfect and working orientation for your gun or the spot gun, so that you're avoiding collisions and all the other problems that your robot can have, like reachabilities or singularities. But on top of that, okay, let's see a quick simulation how it works. So here is just a simple video, 2 robots cooperating and doing some easy spot welds on this part. And here we also rotate the part to a new orientation to get the spots done on the other side of the part. But if we move on to spot importer, so many customers are saying to us that you cannot just pick any point from your part where to create the spot points. So that's why we created the possibility to import the spot coordinates, because typically you are some subcontractor, and for example for automotive industry, and in automotive industry they define in FEM softwares that where they need the spots to be, and they can deliver that information in many formats. And at the moment we have a spot importer which is customizable in CSV, XML, and then also pure custom format can be used. as a service based from us. And here you can see the short video where we import a CSV file that holds few spots on this specific workpiece. And in that CSV file, it can already define the coordinates, but also it can define which robot this points goes, which configuration of the robot you need to use, and so on. And then Delfoi Paint. So first of all, this is meant for wet painting, and we have now been developing this quite few months, and we are able to create the paint result, but also paint thickness results, and we can calculate the accumulation of the paint. So if you run the same path twice, you get the thicker paint, of course. And we can say that on that area at the moment, we are fastest in the world, but we have been testing so far, benchmarking to the other softwares. And now on the right hand side, you can see a short video doing some chick-chack motion on the part. And it's not only now painting the color of the paint, but you can see it's a thickness of the paint. There is a different color for different thicknesses, so you can define any color that, for example, in this case, the green or yellow could be the target color, and you can change your motions and paths based on that you get the homogenized results. Okay, but what is actually the most difficult thing in the paint is how to calibrate your simulation layout or paint simulation to match the reality. And for that, we have created our own calibration tools. And you can see here that it's quite complex window. So it's lots of parameters, and that's how it is in painting. It's not easy process. And here you will see that quickly just by importing the test data from the real robot, we are now adding a new paint brush basically to the robot. So we measure the couple strokes on the real robot, we measure the thickness on different heights, different speeds, and we import that as a CSV file, and then we have an algorithm that fits the simulation world to match the measurements. And then it automatically creates this kind of a paintbrush into the simulation world. Okay, so what else will be there later this year? So there will be a solver bundle for each of these applications, what we showed this far. So solver bundle, what is that? Let's talk about a little bit more on that. What is it? It's a set of tools to solve automatically all the problems that you might have in the robot's path. So there can be reachability, joint limit singularity, collisions, even auxiliary axes can fail. And as you saw in the Vidisha's presentation, she was doing manual modifications to the parameters to fix these issues. But our target is that we get a set of tools to automatically solve these problems to make the customer's life easier. So for example, here you can see how we see it in Delfoi arc, in arc welding process. So solver bundle basically gives you tools to solve the weld path automatically. It also can give you a via path automatically, so how to access from previous path to the next path without collisions. But then we have to be able to solve search paths to touch routine or laser scanning routines. And that all three, if those are solved, then we are able to give you a full automatic solution. So that's the solver bundle, set of tools to give you a full solution. Okay, thank you. That's all from my side.
That's fantastic. Thank you very much. That's very exciting, the things that you guys are working on. I wanted to take a poll earlier, what kinds of things that you guys are investing in this year. Is it paint? Is it cutting? Is it deburring? What is the next robotic application? Are you planning on expanding your welding process there? We just want to give you the tools that you can use to do what you want to do next. So now that's the big question that we help answer. After, how do I program easier, is now how do I fixture my parts and hold them well? And for that, actually, no, excuse me, how do I get this installed? One of the biggest differences between us and any of the other softwares that exist to run robots is we spend the most time and care on the commissioning project. We make sure that the cell is measured, calibrated, it's put in the virtual environment perfectly so that you can very accurately send your code out to the machine. And for that, we have Severi. He's going to talk about our brand new remote commissioning solution. And we've had to do this, of course, as a constraint of COVID, but it's actually been working very, very well. You don't have to pay for plane tickets for us to come down or anything. It works out quite well for us to do this remotely. So I'm going to transition to Severi right now to talk about that pretty cool tool and checklist that we go through.
Okay, first of all, can you hear my voice and can you see my screen?
Yes, very good.
Okay, perfect, thank you. So, hello everyone. My name is Severi Keisala and I'm an application engineer here at Delfoi. Today, I'm going to talk to you about our new remote commissioning projects and our new learning platform. You have now seen the basic use of the software, but of course, for the software to work perfectly, the software needs to be commissioned and the robot cell needs to be calibrated. And as you all probably know, COVID-19 has given almost everyone some trouble with standard methods of working. For us, this especially meant that the commissioning of the software needs to be developed due to the ongoing traveling constraints. Previously, the commissioning required traveling to customer premises, where the layout would be measured, calibrated, and the software training would be held. Our solution for this is the new remote commissioning project. In this project, all stages of the commissioning are conducted online without the need to travel. This does mean that there are some shared tasks and responsibilities with the customer, such as taking the actual calibration measurements on the robot. But it also means that the expenses caused by traveling are going to be eliminated, so no need to invoice traveling costs also means lower product price. So now we're going to take a quick look at the remote commissioning workflow. The workflow consists of 5 steps. So first, a kickoff meeting is held to determine the steps and responsibilities for the project. In this meeting, all calibration steps are gone through and the operator is instructed with the help of the new learning platform. So everything on how to do the measurements and what needs to be done on the project is instructed. Second, the measurements are taken by the operator or optionally, an existing measurement program is touched up on the robot station. These measurements are then sent back to us and we will calibrate the layout and send back programs for accuracy validation. After this validation is successful, user training is conducted with the help of the calibrated layout. Lastly, all steps and their success are reviewed on the final wrap-up meeting just to confirm that everything works as it should. Pilot projects conducted during the pandemic travel restrictions show good results. There are many successful project deliveries with positive feedback from customers, mostly regarding the flexibility and capability just to deliver the project during these times. Request of these remote commissionings has been high, as almost all projects during these times have been conducted remotely, and there still is uncertainty regarding the future of traveling and the second wave of the COVID-19. Beside of the remote commissionings, also the development of our new learning platform is on the way. And now I can share a quick look of the beta version that we are planning to implement in the software. So here you can see the Delfoi Robotics screen. And later on, we are planning to add this documentation button on the tool ribbon up over here. And when we click it, it will open up, we're going to skip the tutorial for now, a window, or more precisely, a web application called the Delfoi Basecamp. But it looks something like this. What you have over here is actually access to theory regarding remote commissioning, offline programming, and calibration of robot cells. You have information on how to perform the calibrations, how to perform layout calibrations on the software side if you're interested in commissioning layouts by yourself. You also have access to different kind of troubleshoot sections, meaning that you will get information on what do you need to do in different situations that you might have problems during the process. You also have calibration exercises and up-to-date Delfoi manuals. So we can quickly scroll through all of these pages just to see what they hold. So they are informative images of different kind of robot combinations, some terminology, and general information regarding the calibration, for example. You also have the option to select robot brands that you are using, the number of robots you are using, or the different kind of layout combinations that you might be using in your own robot cell. Then, regarding those selections that you have made, you will be given the instructions on what do you need to have to perform those instructions, what do you need to do to have a correct calibration, and for example, in what positions do you need the robot to put just to get the calibration as accurate as possible and for the offline programming to work as well as possible. Also, you can navigate through the troubleshoot section and exercises and manual just to get some more in-depth knowledge on what can you do and how you can perform these calibrations. And of course, you will be always associated with the up-to-date Delfoi manuals and different kind of instructions that help you throughout this process. That's about it for my part of the remote commissioning. Thank you all for your attention, and if you have any questions regarding remote commissioning, please send them into the questions box. Thank you very much.
Thank you, Severi. Very good. Thank you for your help with that presentation. That has been a very, very popular way of doing our implementations. It helps us get a lot more done before we come on site. And you know, if you are having people come on site, and it makes the on-site portion go very, very smoothly. Our next conversation we're going to have is about fixturing. Our partner, Camtech, has partnered with us to help with that second question that comes up: how do I create fixtures quickly, and how do I take some cost out of those fixtures? And for that, we are going to be hosted by Rob Thompson here, and I'll make him the presenter, and we'll learn a little bit about his tools that he uses to help his customers.
Well, thank you, Anthony. Good morning, everybody. Hopefully you can see my screen, hear my voice.
Looks good.
Good. Okay. Well, obviously, as Anthony said, what we're trying to do is figure out what is the issue with fixturing and how can we make the design of them quicker and easier. So let me go to the next slide. What are the issues? Well, they take time to manufacture. It can take weeks. Costs can be high and sometimes outweigh the benefit of short-run parts, especially for a job shop. So how do we reduce the time to make fixtures? How do we reduce the time? How do we maximize the welding output? Well, we call it the welding trifecta, and it's basically, as it suggests, it's a three-step solution. The first step is to produce a solid model of the fixture that we need to hold the part. You can do this in your CAD system. Step 2 is eliminate pendant teaching and use a fixture and a solid model of the part to program the tool offline. So you have more time welding and less time teaching. Obviously, step 3 is to produce the parts reliably and quickly on the robot. So here's an example of the fixture from our software being used in a 2-step situation. On the right side is the tacking fixture, on the left side is the complete weld out. So the result is, in the end, we hope to have more productivity and higher potential profits. So Nucleo is our solution to basically make this quicker, increase speed and reduce costs. So we create like these egg crate type fixtures in minutes versus hours. It works out all the intersections and trims and annotates each part of the fixture so you can put it together easily. So just a quick bit of information about us. Camtech was formed in 1983 in Worcester, UK, where I'm from originally. The headquarters are now in Stuttgart, Germany, and our office is in Atlanta, Georgia, where I'm located. And we do the development of Nucleo right here in the States, and I'm one of the lead developers on it. We just go through the steps to get an initial fixture created. We skipped a few steps for speed, but we're showing you the most important pertinent pages. So our first step is we import the CAD model and we orient the part. We get it located above our datum point, get it nicely aligned up. So if it comes in at a compound angle, we can get it squared up. Second step, we set the material thickness for the fixture. So we can set, we can say use 11 gauge or 7 gauge. We can make the base plate thicker, etc. if we need to. Next, we define the base plate. How big is it? And also we can define or import the CAD model of the table you're using. So you might have a trunnion or something on your robotic cell. Here we set the Z upper height shape for the fixture. So we can control the Z height of the fixture so it follows the flowing shape of this part. It's not just a flat top fixture. On this page, we define the positions of the blades that are going to encapsulate the part. So you basically lay out this grid of lines and you can shrink them, stretch them, you can draw your own. Basically, this is a process you spend a little time on just getting the positions where you want to hold your part. We next define the tab feet that marry the blades to the base plate. So there'll be like this interlocking or this little tab that matches the base plate pattern. So you define those parameters. We can insert CAD models of favorite Destaker or Carlane or some other model you've designed, pneumatic clamp. You can place that on the model and it will create a tower onto which that clamp is also located. You repeat that as wherever you need them. We can optionally select a weld body name. So if you have in the model the welds drawn, we can select it and it will look for those welds and it will warn you if you're going to weld the parts to the fixture. We haven't got any in this example, but I've just picked one of the component parts just for example's sake. And at the end, you'll see that it will color the blades orange because it thinks it's going to weld the part to the fixture, but clearly there's none in here. But they're useful downstream for Delfoi. If you do draw the welds in the solid model, they can be picked up for the programming process also. On this page, we set the offset between the part and the fixture, or we can use what we call these gripper points. They're basically bumps that are put on the edge of the blade every interval inch or half inch, and it allows you to adjust the fixture on the shop floor. You can grind them down if there's some error between the physical part and the model. On this page, we can set the weight reduction, so ventilation access. It also makes the fixture skeletal, and it can also make the base plate skeletal also, so you have access with your robot. On this page, we define our base plate hole pattern, which will match your robot table or trunnion. We confirm the geometric and colors, translucency. And on this page, we set the font and where do we want to put the annotation. So it will etch or cut through the part number and basically each blade, so you know which one goes where. And then we finally build the fixture. So we condense this for time. It may take a minute. In reality, it's going through and making it skeletal in my case. And you've got the completed fixture. So if it all looks good, we can export the CAD model as DXFs, IGIS, STL files that are 3D printed files that you can look at on the shop floor on a PC that doesn't have a CAD system. You can just look at them on the shop floor easily. A bill of materials and other information that's useful for the guy putting the part together. As you can see, some of these blades are orange because I marked them as being weld bodies. Okay. Here's a completed view of the fixture without some of the part pieces hidden. And you can see the gripper points, which are little bumps on the edge of the blade. We can perform direct editing functions on it, so we can just lay it down as a sketch. We can remove features or add features, maybe put a slot in there so we can get a pry bar in there to get the part out. Anything you need to do here can be done. So this approach lets you rely on the tools you already own, or certainly have access to. You can cut the parts out on your laser, water jet, etc. You can produce fixtures to suit varying material thicknesses, any sheet material, any stock you have. Does it work for everything? We have weld fixtures made for trailers down to 2-inch, weldments. It's perfect for low to medium production without the need of extensive automation. OEMs such as EasyGo use Nucleo to make fixtures for prototype parts, so it's useful for prototyping too. So basically it's fast and easy. A simple fixture takes 5 minutes and training is generally under 2 hours. So robotic gains, of course, we're looking for repeatable results, fast setup and reuse, just-in-time manufacturing, short-run, high-mix part weldments are easily catered for when we include mixture with the Nucleo in the mix. And of course, when you pair it to offline programming, the gains are further enhanced. So when it comes down to saving money, the trailer ramp, we had a quote for 8,000 for a traditional fixture for this fixture, and we cut it and designed it for 450 in Nucleo. We had a customer who did tractor components, and he had one very similar. It took 40 hours, and he cut it and designed it all the other way around, as it were, in Nucleo in 2 hours. ROI wise, we have one customer trace their ROI in the first quarter and save 6,700, 500 on some smaller fixtures and 3,000 on one fixture. So in the first year they should have saved tens of thousands on fixtures. They were using it for manual robotics, manual welding, but of course it lends itself also to robotics. This customer only bought the software 2 months ago. He stated to us, actually he passed this on to another customer, potential customer, saying he did 32 fixtures in 2 weeks. Prior to that, the small fixture took him 2 weeks. So they're a UTV, ATV manufacturer. We also do a fixture as a service for people who don't want to use or buy software. You basically send us a model, we consult, we do a meeting, and we then model up a fixture and send it back for you to cutting out. So that's really it on my side. Thanks. If you have any questions, just ask in the chat window, and I hope to answer them at the end.
Thank you very much, Rob.
Welcome.
And now we've come to the portion of our time where we can get a little bit more of your questions answered. And there are a couple, let's see, can you see my screen there? There are a couple people that are going to come online now and make their mics open, and you can get your questions answered more specifically. So a couple things that I might use as a starter here. One thing that came up specifically regarding structural steel, that's a little bit different of a presentation that we've done before than what you saw today. We have a pretty slick little tool that we can use as a import from Tekla. We can use some of the welds that are modeled in Tekla to automatically program and apply the welds, do the collision checks, basically let the software do all the work as far as robot programming is concerned. But that's a little bit deeper of a conversation. We have to make sure that you're preparing the Tekla file correctly. But structural steel, our broadcast there is a little bit different conversation. If you're interested in that, we could certainly break away and have a conversation there. But are there any questions from what you saw today, from the basic programming to the more advanced applications? Let's see. I've got one from Gordon Atridge here. It says, does Delfoi have an auto program generation mode for CAD programs like Tekla and SDS2? Yes, that's our structural steel. Vesa, can you at least speak to that a little bit?
Yes, so we have done now a few projects where we import IFC files, and from there we generate the CAD geometry, the workpiece, but we can also import the weld details defined in IFC file. So based on how you design your welds in Tekla, and we can import those via IFC, and then it's up to you if you're using the basic Delfoi arc to make sure that it's welding everything correctly, or if you want to include the upcoming solver bundle to automatically try to solve those imported welds.
Absolutely. One person asked a little bit about OEM software that comes with a machine. You know, some welding software that comes with like a Fanuc Weld Pro or MotoSim with a Motoman robot, or some others, and how we compare to OEM software. You know, I deal with that question every single day, and I've got my own opinions, but is there, based on your experience, guys, maybe Juha can answer some of this, a little bit of difference between what OEMs do for their customers and what we can do for our customers?
Well, in short, normally we want to show the difference with the layout and the part that customer wants to program. So that's the easiest way. So I don't want to say too much about Weld Pro, if it's good or bad, but I think the main differentiator is that the programming speed, basically. And of course, with Weld Pro, you can only program Fanuc robots. So if you have different brands, you can do all that with our software. But the speed is the main thing, and of course there are lots of tools that makes the speed happen, but that we would like to show on live with your parts and your layout.
Yeah, that's a great answer. Yeah, that's definitely a great answer, Juha. It's very dependent on what you're trying to do. If it's just one straight line weld and that's it, that's all you have to do on a part, I'm sure, you know, there's not a multiplication of savings that we could, you know, do. It might take you long to make one weld, but if you've got a multiplication of welds there and you're doing this, you're trying to get more parts on there, you have more of a mix, you have a higher volume of parts, and a higher mix and a lower volume of parts. And if you're programming all the time, or if your programmer has to wear a bunch of hats, let's look at your parts, let's put it on your weld cell, let's model it up, let's go through and click around your parts and get a benchmark together and say, hey, we were able to program this part in this long, and here's how long it took. Plus, once we do program one part, often the tools for programming the next part is much easier because of how we save the WPS and the templates and the weld feature templates. So for sure, we want to make that easier for you. Do you offer training by distance? Yeah, we sure do. That's part of our remote commissioning process there. We do the commissioning, and then we, of course, offer training remotely. Ideally, we'd like to train you on site. We normally spend a day and a half on the tools inside the software, but then we show you the tools in application to your part. So, we want to put your parts in our system and begin getting you programs out to the shop floor by the end of our training. So that's in addition to the implementation. You'll get training as well. Let's see. There's a couple more. Are there any more questions that we have come up with? Did everyone see that this could be helpful? This pathway, this flow through the software, once it's dialed in, we want you spending as little time with the software as possible and getting through these things. Hopefully this was a help to you. Any more questions? Of course, if you do type any questions after the fact or something right now, if you're typing right now and enter them, we will of course answer any of your questions and get back to you. One of the benefits of today's webinar is that we've recorded it, and that everyone, even if they couldn't attend today, gets a copy of this webinar, and so we'll send it to you via your email. If you're interested in getting a little bit more closely into the software, one of the things that we talk to you about is your specific parts and your specific weld cell. Also, once we do that, we'll talk about pricing as well, because it could depend. There's a range of solutions that we can offer that we need to get to based on your configurations. Also, we'll help you come up with an ROI. There's a wonderful ROI tool that we've developed that shows about if you're manually welding today, how much it costs. If you're robotically welding today, how much it costs you with your traditional method, either the OEM software or the teach pendant programming that you're doing, and then how we compare with your parts programmed in Delfoi. And that we are seeing, depending on how busy customers are, if they're trying to put more parts on a welding cell, we're finding that our ROI is 6 to 8 months in a typical configuration. When we get to that point, when we start to discuss pricing, and when we start to discuss the ROI, it's typically much less than a year. It's typically in the 6 to 8 month range. So hopefully today's, okay. I just got another question. We're going to try to answer this. Is it possible to share my commitments on the web seminar to my LinkedIn profile? I'm not exactly sure. You know what? I'm not exactly sure about that. Well, let's talk about that later. We'll make sure that you can get the copy of the webinar and you can share it. Feel free. All right. Our contact information, I do want to flash that on the screen here. You'll get that in an email here, but if you want to get in contact with us later, you certainly can, and we'll be happy to do that and have that conversation. If there's no more questions, we will resume let you get back to your day. Let me share my screen here and show screen here. And there we go. We have reps on the East Coast, and I cover the rest of the nation. And you can see You can get our email addresses here. You can jot them down, but we're certainly happy to help you whenever you need us. Okay, thank you very much, everyone. I hope you have a great day.
Thank you, guys.